An insurance company has an equal number of claims in each of the three territories. In each territory, only three claim amounts are possible, 100, 500, and 1000. Based on the data, the probabilities of each claim amount are given below. Find the standard deviation of a randomly selected claim amount. So the main thing here is that the three territories have equal number of claims. And it can be shown that in this situation, each claim amount will have a probability that will be the average of the probabilities of the three territories which contribute to that. And I will demonstrate this at the end of this problem. Let's for now assume that in this situation where there are equal number of claims, we can find the probability of each claim by averaging out the three territories. And after we get the answer, I will use an example to demonstrate why this is so. Okay, so what that means is that the probability of a claim of 100 will be obtained by averaging the three probabilities of the three territories here. So 0.9 plus 0.8 plus 0.7 over 3 is 0.8. Similarly, 500 claim, the average, the probability of the claim of 500 will be obtained by averaging these three probabilities. So that 0.08 plus 0.11 plus 0.2 over 3, that's 0.13, and similarly for the 1000, it's 0.07. And so we have the three claim amounts, 100, 500, and 1000, and these are their corresponding probabilities. So again, we can do it more quickly by just plugging it in calculator. Let's do it. So let's clear the data first. So hit data twice, enter, that clears this one, and again hit enter, data. And now let's clear L2. Okay, and now everything is cleared. So the three claim amounts were 100, 500, and 1000. Enter. And then we scroll over for the corresponding probabilities. Now the probabilities were 0.8, 0.13, and 0.17. 0.07. So you can enter these, or you can enter a multiple of these. That saves even more time. So if I multiply each of these by 100, this is 80, this is 13, and this is 7. So I can enter that as well. So let me do that. 80, 13, and 7. 80, 13. Because these are just weights. As long as you keep the same relative lengths, they are going to give you the same answer. So that's it now. And now second data. Enter data in L1, frequency in L2, and calculate. And so we see, remember, we're always looking for the population one. So the population standard deviation is 253.5, and that rounds to choice A. Choice A was 254. So the correct answer is A. So now let me give you the promised demonstration that in case of equal claims in the three territories, we can average out the probabilities like this. So I've just rewritten that table, and now suppose each territory has 200 claims. So 200 in territory 1, 200 in territory 2, and 200 in territory 3. So I've just copied that table again that was given. So these were the three claim amounts, 100, 500, and 1000. And previously, we had these probabilities, 0.9, 0.8, and 0.7. So now we know that each territory has 200 claims. So if the probability of a claim is 0.9 over there, then if there are 200 total claims, then there will be 180 claims. Corresponding to this situation, 180 claims in territory 1 of amount 100. And similarly, the probability was 0.8 in the table, and we are assuming that every territory has 200 claims. So 0.8 times 200 gives us 160 claims in territory 2 of the amount 100. And similarly, the 0.7 times 200 gives us 140 claims in territory 3 of amount 100. So that means the total claims of amount 100 will be the total claims of amount 100 in the 3 territories. So you add these up, you get 480. So we have 480 total claims of the amount 100. Remember that we are assuming that each territory has 200 claims. So there will be a total of 600 claims in the 3 territories. So the average will be the total claims divided the total claims of that amount. So P of X is equal to, so here the total claims here mean total claims of this amount, of the amount 100. So the average of the amount of the average of the 100 claims will be okay, let me rephrase it. The average of the probability of the claim amount of 100 will be the total claims of amount 100, which is 480, divided by the total claims period, which is 600. So that's 0.8. So we do the same business with the 500 and 1000. So we find that there are a total of 78 claims of amount 500. And since the total claims are 600, so the probability of a claim amount being 500 is the total claims of amount 500, which is 78, divided by the total claims period, which is 600. So 78 over 600 is this, 0.13. And similarly, this one is 42. And 42 over 600 is 0.07. And these were the probabilities that we got above the 0.8, the 0.13, and the 0.07. So that's just a demonstration. I took an example of each territory having 200 claims and demonstrated that in this case we can average out the probabilities. But if somebody wants a more mathematically rigorous proof, then instead of supposing that each territory has 200 claims, you can suppose each territory has Y claims, and the exact same procedure will again result in the same thing. Okay.